Hello and welcome to the first day of C, day 2. I'm going to show you how to write your first program in C and how to compile it so that it can be executed by the machine. First, let's open the file joule02.c with Emacs. The .c extension lets us and the machine know it's a source file. As soon as you open or create a file .c with Emacs, use Ctrl-C and Ctrl-H to generate the school header. If you're using Vim, you'll have to use function fnf1. We'll start by declaring our program's entry point with the function main open brackets. In C, all functions have a type, integer, char, etc. They return a value of that type whenever they are used. So here we're going to create the main function which returns an integer. If your function doesn't return anything, you'll have to write void. Void equals null. No variable means nothing to return. As our function main returns an int, let's write the return now. Assuming there was no error in our code, we'll use the default return code, return 0. The 0 indicates everything went well. Normally, main takes arguments, but for your first program, we won't. Here we go. We created a function that does nothing but return 0, just saying everything went fine. Let's save our file with Ctrl-X, Ctrl-S. With Ctrl-Z, Emacs will run in the background. You can see in the shell the task was suspended. Now, let's compile our file with GCC, which is the compiler. GCC has several options. For instance, -O, which allows us to define the type of GCC output file, meaning the name of the executable we've created. So let's create an executable called joule02 using the source file joule02.c. Be careful not to mix them up, otherwise you'll overwrite joule02.c. There we go. GCC has created our file. See in our directory, we now have two files, joule02 and joule02.c. We now have the executable. You can see that through the file's access rights. To make sure we're executing it in the current directory, we'll use / before our executable's name. That launches our program, but as it doesn't do anything, there's no output. So let's make it do something. With FG, we go back to the foreground, which reopen Emacs. Let's use a basic system call, write. So, if you remember, or not, we'll use write on the standard output, which is the file descriptor 1. We'll just display one character, for instance, the @ sign, and specify how many characters we want to display from this string. So here, just one. Let's quickly check out write man. We can do this simply by doing -x man. We'll look at the man to write. Write is a system call. Mans are indexed by type, and man2 is about the man page. So we want to type man2 write. It splits our window into two. To switch windows, just do Ctrl-X0. And you can see write requires the header #include angled brackets unistd.h, so that the compiler has the declaration and knows what arguments are required. And what the output parameter is. So let's add this header. So Ctrl-X0 to switch windows. We can see that write requires a file descriptor, the one that represents our program standard output, a buffer, which is a string, in our case just the @ sign, and a size, number of bytes to be displayed. Save your modifications, Ctrl-X, Ctrl-S, suspend Emacs, Ctrl-Z, recompile. Everything went fine. Launch your program, at is being displayed on screen. Why is there a percentage at the end? Because there's no carriage return in our program. So let's add one. Exclamation marks and change the size of our string to 2 characters. Recompiling, relaunching, that's better. Now that we've created our first function, let's move it to a sub-function, which we call ft_putchar brackets, which will also return an int. So ft_putchar brackets will take a char c and will simply take the right. From the main and move it up. Cut the line with Ctrl K, do it twice to get the carriage return, paste with Ctrl Y, and in our sub-function we'll be able to write the character. It's a little complicated. With ampersand, we give a character's address instead of the character itself, which allows us to transform it into a string, a char star, here we can either return 0, which means everything went well, either change the function's type to void, returns nothing. Let's use return 0. We're going to use our function ft_putchar brackets, and this time we'll use simple quotes because it's a character, not a string. We're going to do this a second time for the inverted commas. Let's close the main window with Ctrl X1, and you can see our program will start its execution from the main. The main calls the sub-function ft_putchar. ft_putchar displays what we put as a parameter in the char c. It returns, then we're back to the point of execution at the end of this function, then we carry on. And then we end up with a ft_putchar of a line break blank. In this case, write 1, the char c becomes blank. It's 1 character, so 1, we return, and we're done. Let's test this, Ctrl X, Ctrl S to save our program. Recompiling, launching. It did what we wanted. Now, let's try something a little more complex. Let's create a function that displays n times the character passed as argument. Let's call it ft_nputchar. So we need the character we want to be displayed, and an int for the number of times we want that character displayed. Here we'll simply use this int n to count. We could modify it the hard way, but let's try and keep it simple for now. We need a counter I, which will start from 0, and here we're going to add a loop with while. While I is smaller than n, while bracket I less than n, will display the character. By calling our ft_putchar function. And as long as it's lower than n, we'll increase by I equals I plus 1. And once I is equal to n, it'll stop. So if we say that the argument n is equal to 1, we start with I, which equals to 0. Therefore, it goes up to 1, starting our first loop. We increase I by 1, so I goes from 0 to 1. The loop starts over again. As I isn't lower than 1, the expression is wrong. So we exit our loop while and return 0. So we'll try the same thing. Here we'll call function ft underscore input char and ask it to display 42 times the character at followed by an asterisk. Control Z, Emacs run in the background, recompiling, launching. Okay, let's check. Normally we should have 43 characters because the space counts as a character. Here we go, we have 43 characters. With these simple examples, you should be able to write your own programs in C. Up to you to do the rest. Cheers!